One of the challenges in building something complicated like a tree is the chicken and egg scenario of how do I know if add is working before I continue on to the other functions, remove and contains and all these other different things. Um, so one of the mistakes sometimes that we can make when we deal with automated testers, if we pass the test, then it must work. Uh, it's certainly passing one test, it must work. Hey, I passed the add test, everything must be right, right? So we need to kind of be able to see what we did was right. And so this next, scenario, what I want to do is talk about this print structure functions method. The print structure method I created. It's not part of a normal tree structure, but it's to help you visualize the tree. Now we're not going to make a perfect visualization. We're going to have to have your brain do some of the work still, but I want to do something to show you how to see your tree from a debug standpoint, but also how to get something working before everything's working. So I'm starting with an empty function here. Nothing's inside of it. And so my choices are I either have to make add work and then I can go build print structure, or I can make print structure work, but then how do I add stuff in? Right? It's kind of a chicken and egg scenario. Um, well, let's start actually by just saying like, hey, forget the test case. Let's just make print structure work on its own. What if I just create my own tree structure? So hopefully you figure this out. I might be giving away something here, but we have our node class defined for us, but we need to actually have a um, root node to start with. So I'm just going to go ahead and throw that out there because I'm going to need that anyway. And so I'm going to set that root is going to be a new node. And I'm going to just set that value to be 1. I know my test cases use A, B, C, and this will help differentiate it, but it also, in my head, will make it easier to see, we're just going to 1, 2, 3, 4, 5, 6, 7, 8, 9, into the nodes. Actually, can only go up to 7. Now, first thing you see here is this, hey, node string is undefined. Change constructor to be string or create constructor node string. I don't want to do any of those quick fixes. This is somebody else saying these are the things you want to do, assuming what you wrote down was the right thing. And it's not what I want to do. It's not what I wrote down. What's happening here is I had to, because I didn't want to have you get drowned down in generics in Java, I had to kind of compromise and have this variable be a comparable as opposed to you being able to set it whatever you wanted to through a generic. And so all I have to do at this point is cast my string to be a comparable. Strings are comparable by their very nature. They're defined as such, but it doesn't recognize it for whatever reason. So I'm just going to work that around in Java. So this is my first line of code. I've created a tree of one root node, but let me add in a left and a right. So I'm going to say the left node is going to be number 2, and the right node is going to be number 3. Um, so I could leave it there. I'm actually just going to build the rest of the structure I want to test with for the moment because I want to see. I want you to see, all of it in place. So I'm actually going to copy these two. I'm going to paste them twice. The reason I'm going to do that is every one of these nodes, and so the left node is also going to have a left node, so left dot left, and the right node is going to have um, a, a, a left node as well. So I actually am going to reorder these, and then so let me build this and I'll explain it because I'm overloading my brain for a second. So yeah, so here, let me move this around. All right, I could have copied and pasted this in a more sensible way, but I didn't. So my left node has its own left and right node, which I'm going to call 4 and 5. And then my right node has its own left and right node, which I'm going to call 6 and 7. So essentially what I'm looking to do is build a tree where 1 is on top, and beneath 1 is 2 and 3, and beneath them is 4, 5, 6, and 7. And this is not the format I'm looking for necessarily. We'll talk about that later on, but at least you can see, hopefully here, the tree that I'm looking to build, 1, 2, 3, 4, 5, 6, 7. All right, that's a full filled tree of 3 layers, 3 levels here. Um, so that's the little test case I want to start off with. Now, the code to print this then can build off of this test case. Now notice I'm not actually changing the test case. I'm putting this right in here. And I just want to keep your life simple. I don't want you to accidentally screw up the test case necessarily here and not be able to recover it, though you can always replace that file or just undo or whatever. So that's why I'm starting it right here. But I am going to actually use a test case to drive this here in a second. But I want you to see this code here. And maybe if you weren't able to type all this in, go ahead and pause until you get this together, and then we'll go from there. Um, okay, so I'm assuming you've paused and caught up here. You got all this code ready to go. So now I'm going to go ahead and run my simple tree here. Let me go ahead and run this, my simple tree test, and everything failed but print structure. Um, and print structure actually didn't fail because I already commented out one line of code here. This is going to be in there by default. Let me actually just run it again because I forgot that I would comment that line of code out. So everything's going to fail, including that line of code. But when I fill the tree, it actually does a test. So that way, if your test is broken, the print structure can't work because you can't add to your tree. So that just is a signal that you're not there yet. But I'm going to comment that out for a second. This line 109 of the test case, if you will. It's not the end of the world if you forget to uncomment it. It'll still print everything out. But when you get your tree working properly, it won't actually fill it. You won't print something out properly. So don't forget, ideally, to undo this. So, but again, I have print structure coming out here, but it's not doing anything yet. But it is, my test is set up to do something. So what do I want it to do? Well, theoretically, I could say system.out.println root dot value. That's the base of our tree. Let's go ahead and just show that everything's working. One, it printed out one. That's the base of our tree, right? Now, this is going to be a pain in the butt, and I have a bad habit of hitting run every time because that's good in general. But for here, if I just want to run the one I care about, if you have other print going on or whatever, you can always go to JUnit and say run an individual test, which then, again, just runs this one, right? Now, printing a tree in tree order is actually non-trivial. In that if I want to print a tree in comparable order, so let's just say numeric order, alphabetical order, starting with A going to Z, starting with 1 going to 1,000, whatever that order would be, I can actually do it recursively and just kind of navigate the whole structure. And that's actually what you would do in the toArray function, which is also listed in a different video. By the way, another great test, if you want to, you could print it out that way, but it doesn't necessarily show you the structure of a tree, so maybe not as good for testing add. That's why I want to show you this one here. So I do actually want to use recursion, but again, if we think about that tree structure, one, 2, 3, 4, 5, 6, and 7. I need to print out the 1 on the first line, which is the root. That's easy. And then I need to print the left and right of the root on the next line. Well, theoretically, that's easy too, because I just go to that next one down and print the next, the left and the right. But if I do it recursively, I print the 1, and then I do it for 2, and then 2 would do it for 4, and then. But wait a minute, if I'm printing 4, how do I print 3 on the same line, in this case line 81? There's actually a little paradox here, a conundrum. So if you were trying to figure out how to do this algorithm on your own, you would do it recursively, where you step down each time. But the problem is, if I print within that recursive algorithm, how do I know what goes on which line? Ideally, I want to finish line 80 before I print out line 81, before I print out line 82. But once I move down to the left node of here, I can't move back up and remember where I was again. I can only recursively move it down. So I am going to do it recursively because trees are very good recursively. And so I'm going to have a second function here that I'm going to help myself with. So I'm going to call this function print given level. All right. And I'm going to print a node, which is going to be a subtree of the main tree. It could be the whole tree, but it's going to be a subtree most of the time. And I'm going to print at some level. All right. And so, by the way, I need to make this I'm going to make it private because nobody else needs this, and it's not going to return anything, so it's going to be void. And that's going to help me work on this tree. So what I'm going to do is I'm going to print all of this level, then I'm going to print all of this level, then I'm going to print all of this level. So I'm going to do recursion, but I'm going to only print out the level that's given for the tree that's given. It's going to be a different approach to how this is going to work. So let me, well, we're about, let's see, 10 minutes in here. Maybe we'll take a break in a second, but let me do one more thing before we get there. So basically, let's just say that if the subtree is equal to null, well, we have nothing to print. We have nothing further to do. And so beyond that, what we want to do is we want to print out everything when we reach the level that we wish to print out. So if we want to print out the whole tree, we want to print out, going down to not just the first level, the second level, we get all the way down to this third level that's going on of the tree. But remember that in the tree terms, this level, quote unquote, is referred to as the height. So this is not actually level 1, this is level 0. This is level 1, this is level 2. So let me real quick, as part of my test case, I'm going to alter the height here. My height is actually right now for this tree going to be 2. If it only has one note, the tree's height is 0. If it has 2 levels, its tree height is 1, and so on and so forth. It's a little CS thingy to kind of mess with your head a little bit, but a tree of 3 levels has a height of 2. All right, so that's what we're shooting for. I'm gonna get out of the way so I can compile this. Here we go. So right now I'm just gonna fix the height of my tree to be 2 for the moment. And so what I'm gonna do is I'm gonna print each level at a time. So if the level is 0, then what I want to do when I reach level 0, well, I want to I'm sorry. Yeah, so if level 0, yeah, I'm sorry, system.out. I forgot what I was doing here for a second. I want to print out the value. All right. If it's not level 0, then what I want to do is shrink my level until it gets to be 0, right? So I'm going to start off printing the root, which is level 0. I'm going to print everything on level 1, then I'm printing everything level 2. So if I get down to level 2, well, what I want to do is say print given level for the subtree dot left for level -1. And then I'm going to do the same thing for the right subtree. So think about this. I keep erasing it, but let's come back over here instead of saying print here. Let's say print given level of 0, of root comma 0. Let's see what it prints real quick. So theoretically, I put in the root. The root's not null, so the level 0. So I'm going to print out the value of null and then go from there. All right. So let me just start with that, and I'm going to try and remember this. Right click and run. So I have to run this 1. Well, I print out 1. It's cool. So now let's test it out where I say print out level 1. All right, so let's run this again. Okay, well, it printed out 2 and 3. The good news is it printed out what I expected to. The bad news, they were on separate lines. Well, let's test it one more time to say print out level 2. Save that. Run one more time. Yes, so I printed out 4, 5, 7, 6. I might have moved those 2 backwards here. Yes, I made left and right. But that actually proves the fact that my tree is printing out what I want to do. So hopefully you're with me here. I'm going to take a break here for a second, let you take a break and catch up. But you can see what we've managed to do is we're printing this tree. We can print any level of the tree one at a time. So obviously the issue is somewhere right here to be able to print the line as a line, and we're going to come back and fix that. But before I do that, let me just let you catch up. I'm going to move this code so you can kind of hopefully see it all here. Um, and let you catch up and do this and get this part working, run these couple tests I did, and then come back to the next video from there.